that page to yourself. What do they mean by a magnetic field? What do you think they mean? We have a magnet. We've talked about magnets. Who can tell me about a magnet? What do I know about this? Adam, give me a fact.
It sticks to metal.
All right, good. It's going to stick to metal. What else? Tell me something else.
Sticks with south.
North sticks with south. What else?
Steel.
It sticks to steel.
Sticks to iron.
Iron.
If you put those to north, it won't stick.
It won't stick if you put like poles together.
Put this certain thing on it, and then electrons won't be able to just make it work.
Very good. All right. This is a very special kind of metal. It's been what we call magnetized. Remember, we have a north and we have a south. And yes, we need the electrons to flow through all the time so we don't end up having a problem. Now, in the book, they said they put a magnet down and then they showed you a magnetic field. What are they talking about? When you look at the picture, can somebody tell me, what are they saying when they say that's the magnetic field? What are they talking about? Jimmy?
Like a certain area that attracts stuff or a certain amount.
Very good. Let's see if I can create a magnetic field up here on the overhead. What I have is iron filings. In other words, they've just taken up some pieces of nails or iron and cut it all down, and it looks almost like pepper. You want to be careful, though, that you never get this on the magnet, because it's hard to come off. Am I creating the magnetic field like what you have in the book? Yeah, that's right. Okay, the magnetic field is where you see the iron filings doing what? What do you think? What are they doing, Sean?
Attracting it.
All right, good. That's a good way to say it. You're kind of attracting it. If I take a look at this part out here, can you see this part out here? I want to hide it. Out here around the edge, are those iron filings doing anything other than just sitting there? How many people think they're just sitting there? How many people think that they're doing something? How many people think that they don't know? Take a look at it. Here, do you see these iron filings doing something in that section? Can you see how they're definitely kind of being pulled one way or another? When I go out here, are the iron filings being pulled anywhere, or are they just kind of sitting there? Take a look out here. Does it look like they're being pulled one way or another? Or they're just sitting? They're just sitting there, aren't they? That's because those iron filings are beyond what we call the magnetic field. There is no pull out there. The iron filings cannot feel that. Right? It's out of its reach. Almost if I went outside and you people were playing outside, and suppose you were right on the swings, and I came out here and I yelled really loud and said, "Time to come in." Could you hear me? Maybe. How about if I'm out there and I yell and blow my whistle really loud, will you hear me if you're at those swings? Yes. So that would be being within the magnetic field. However, suppose 4 of you go over to the high school, and you're out behind the high school, and I stand here and start screaming for you to come back. Are you going to hear me? I don't think so. That's the same thing that's happening with these iron filings that are outside. They're too far away to be feeling that attraction. They can't feel that pull. But these iron filings that are right here, they're close enough, they feel it. Now, what can you tell me is happening at the poles? First of all, where are the poles? Roger, where are the poles? Good, at the two ends. Notice what's happening at the two ends. What's happening? Adam, what's happening?
They're contact with it.
happening in your book. Look on page 160 in your book. Does it look the same? Do you see how it's being pulled to one end? Put your finger on one end so I know that you know what I'm talking about. Wrong page height. Okay, now put your finger on the other end. You see how the iron filings are being pulled to either one side or another. Now, look at the middle. Look at this middle here. What do you think's happening in the middle? This sometimes happens to people too. Jesse, what do you think's happening in the middle? Katie, what do you think's happening? Okay, are they going to one side or the other? Staying in the middle. They're kind of stuck in there. They're stuck in between. It's kind of like somebody calls you up and says, I've got tickets to the best movie. Do you want to go? And then another friend you had talked at school has tickets to a different movie. And you want to go see that one too. You don't know which one you want to go with, right? You're being pulled between. Or somebody says to you in the morning, do you want to play with me at recess? And then another person comes up to you and says, I have the pass, I can use the computer. What are you going to do? You're being pulled both ways. That's what's happening to these iron filings in the middle. They're being pulled both ways. They don't know how to go. They're mixed up. They're just going to sit there. So the magnetic field is everything around here, but it's most powerful at the two poles. Great. Now I want you to read, look at the page, page 161. Do those magnets look a little different? They look a little bit different, don't they? I want you to read that page to yourself and see if you can tell me what's happening in the first picture and what's happening in that second picture. It's your turn. What does it look like is happening in that first picture? Todd, what does it look like?
The two poles on the middle, the magnetic field of the two poles are like.
Well, you read it right off, but I want you to tell me in your own words what's happening to those iron filings. Think about what you know about like poles. Heidi, what do you think?
Two ends of the poles are the magnetic thing. They're getting pulled each other together. They're getting pulled together.
In the first picture? In the first picture, they're being pulled together.
Yeah.
You think so? Roger?
The poles are close to each other, so they're stuck in the middle.
A little bit. What are the two poles in that picture? We have to go back, I think. Step back a step. What are the two poles in that first picture, Sean?
One comes out.
I don't think that's what it says. What is it? Read for me right under the first picture, Sean, and tell me what it says.
Magnetic field of two poles that are alike.
What does that mean if the two poles are alike? And what happens when we have two poles that are the same? Do you remember? Ooh, I think we forgot what we did. When we have like poles, what happened? What happened, Adam, when we did this with our magnets?
So they get pulled away.
Yeah, they get pushed apart. The magnets push apart. Remember when we all got our magnets out? And we took a south and a south? And we put them together? What happens? They get stuck together. I want you to, you're forcing it together. Lay it in your hand and lay it in that hand. No. Just lay it in that hand. Bring it together. Are they going together? What are they doing? They're spreading apart. How many people remember that? Remember that? When you pushed the magnets together and you couldn't get that push together. So they're pushing apart. That's what's happening. We have two poles that are alike and they are pushing apart. Now let me see if I can see who's who here. Okay, so if I have a south pole here, what do I want to bring in to make it look like that picture, Shane? Whoops, that picture has like poles, a south. Here I come in with a south pole. Watch the screen and see what happens at the end of the magnets. What did those metal filings do? Did they come together? What did they do, Sean? They moved away, you bet. Those two poles that are alike are pushing apart, which is pushing apart the iron filings. The iron filings are saying, no way, I want to get out of here. That is not where I want to stay. All right, if this is a south and this is a south, what is that pole? Okay, a north. So now I want to create that other picture. What's the other picture's poles like? Nicole? A north and a south. So if this is a south, if this is a north and a south, and that's a south, this is a what? North. So what do I want to bring in? So I want opposite poles. South. Okay, watch the iron filings and see what happens on this. What happened? Whoa. What happened? They got together. Look at what the iron filings are doing. What are they doing? Do you see this connection that's happening there? Can you see it? Oh, you can't see it. Okay, magnet. It's not doing what I wanted to do because I got too close. Okay, let's see if we can fiddle this around again. Okay, try not to bring it super close. So we've got our, remember it's going to be attracted, isn't it? Can you see the difference? Now you have the iron filings going between them because they're attracted to both ways. At the other end, they were saying, no way, I don't want to be here. They were being pushed apart. At this end, they're being attracted together. Okay, so take a look at that picture. In your book. The first one is like poles. Put your finger on that picture. Like poles. Like poles. Put your finger on the picture because I cannot tell if you're not on the right picture. Look at the space between the iron filings. Can you see that they're being pushed apart? Now take your finger to the other side. The other side, can you see the iron filings forming between? Because they're being pulled together. Right? That's very important. Magnetism. What is an actual giant magnet? What is a big magnet? What? Oh, okay, right. We have lots of giant magnets we use. But can somebody tell me what is the biggest magnet that we have? The Earth, right. The Earth creates this magnetic field because the inside core, they think anyway, is made up of an iron, which is creating a big, gigantic magnet. But what's the poles? Where are the poles of this gigantic magnet? Where are they, Felicity? Sure, the top and the bottom, the North Pole and the South Pole. North Pole's positive, South Pole's negative. So we have this big giant magnet. We have something that we can really use. Because we know that the Earth is a magnet, we can use this and not get lost when we go in the woods. What could I use if I'm going in the woods? What, Shane?
Compass.
A compass. That's right. And many people have all sorts of different compasses. And that's what a compass looks like. And what we're going to do now is we're going to try to learn how to use a compass. Because lots of people have these little things, and they have no idea how to use it. So if they went out into the woods, they just would walk around silly. Anybody have an idea as to this compass? As to how to use it? Is anybody a Boy Scout so that you know how to use it? How do you use it?
When the arrow is pointing north or north, well, the numbers in between, if it's pointing to one of those, you're either going northwest or northeast, then it will say 25, 45, and let's say we're going northeast 45.
me about the compass's needle? Watch. Watch the compass. Come on. What can you tell me about the compass?